Okay, so let's work through the following question. So a hemisphere has a total surface area of 75 pi centimeters squared. So a hemisphere. So let's think about that. Okay, so a hemisphere is going to look something like this. So when you're getting its surface area, you're getting, so let's say this curved surface area, and it's the underside of it as well. So that's what it means by the total surface area. It's not just the curved surface area, it's the underside and the top as well. So the formula then that we use to get that is this guy up here. So it's this, so total surface area is equal to 3 pi r squared. So what we want to do is we just take what it gives us and we substitute the values into this formula here. So I'm just going to work on this down here. So total surface area is 75 pi. So that's, we've just taken that from there. So that's the total surface area is equal to 3 pi r squared. And r is the unknown. This is what we want to get. So what we can do is, like, straight away what we can do is we can get rid of pi, and this pi. How do we do that? We can divide both sides by pi. So if I divide this by pi and divide this by pi. So this means 75 multiplied by pi. Now so what I'm essentially trying to do is I'm trying to turn this pi to a 1. And how can I do that? So if we're dealing with multiplication, the opposite operation of multiplication is division. So I know that if this is 75 multiplied by pi, then the operation that I have to use is the opposite, which is division. So I have to divide this by pi. If I divide this side by pi, I have to divide this side by pi. So these are rules that you have to use when you are manipulating the formula. So it's to keep both sides balanced. Whatever you do on one side, you have to do exactly the same on the other side. So what's going to happen then is with this, so pi will go into pi once, pi will go into pi once, like that. Pi will go in here once, and pi will go in here once. So then what you have is it's 75 multiplied by 1, which is 75. And it's technically 75 multiplied by 1 over 1, but 70, so that you can just write that as 75. So if you have any number, let's say, so if you have the number 2, for example, you can write that as a fraction by just putting a 2 over 1, like so. You don't put the 1, you don't imply it's there, but you don't put the 1 there, but it's implied that it's there. It's the same thing as well as if you have the number 2, there's a 1 in front, it's 1 multiplied by 2, but you don't put the 1 there. It's just implied. So it is. Okay, so that's what we mean. This is the basis behind what we're doing here. So that leaves us with 75. So 3 by 1 gives us 3, and then by r squared gives us 3r squared. And again, that's 3r squared over 1, but we don't need to put it over 1. It's just implied that it's there. So we have 75 by 3 by r squared. So now the next part is what we want to do is we want to get rid of the 3 that's in front of the r here. So this means 3 multiplied by r. So again, we're back to this operation. We have to divide it. So what can I divide 3 by to turn it into a 1? I divide it by itself. Divide it by 3. If I divide this side by 3, I have to divide this side by 3. So that will go in there once, that will go in there once, 3 will go in here once, and 3 will go into 75 25 times. Yeah. So now what we're left with then is, so this is just 25 is equal to 1 by r squared is just going to leave your r squared. Now again, what we have here, we have an index. Okay, so if I have r squared, the opposite of that is going to be the second root, or the square root of r. So in order to get rid of this square here, in order to get rid of this index, I have to get the square root of this. So the square root just means the second root, or the square root. So if I get the square root of this side, I have to get the square root of this side as well. So what's going to happen is these two will cancel out, and that will just leave you with r. So r is going to be equal to the square root of 25, which is 5. But if we look on the calculator, so second function, so see here we have the second root, or the square root. So if we could take 25, get the second root of it, so that's equal to 5. So it's equal to 5. Okay, and that's our answer there as well. So the radius is equal to 5 centimeters. 5 centimeters. So the next one then is this here. So find its volume in terms of R. So the volume of a sphere will be this. We use this formula here. So this is the formula that we're going to use. So what we need to do is we need to manipulate this formula. So let's work through this one. So, and what it's asking us to do then is that you want to write this in terms of pi. So what does that mean? So we don't know what its volume is, so it doesn't give you the volume, but it just wants you to manipulate it and write it in terms of pi. So volume is going to be equal to 2 over 3 times pi times the radius, which we've worked out here is 5 times 5 to be cubed. Okay, so then we can continue writing this. Now let me just move this hemisphere out of the way so I have a bit of space. So let's work this out. So 5 to be cubed, so that's just 5 by 5 by 5. So let's cancel this. So 5 to be cubed is 125. So this is going to be pi times 125. 2 over 3 is equal to the volume. So then what we do is we multiply 2 by pi by this. So it's going to be 2 multiplied by pi multiplied by, well actually we want to write everything in terms of pi, so we don't need to multiply out pi. So we can just multiply 2 by 125. So it's going to be 2 multiplied by 125. That's equal to 250. So then this is going to be equal to, so the volume is going to be equal to 250 pi. So that's just, we've multiplied this by this, and we're retaining pi. We're not multiplying, we're not multiplying pi. So it's going to be 250 pi over 3. Okay, so you could write this is just the same as like that example. So then you're finding its volume in terms of pi. So its volume in terms of pi is going to be volume is equal to 250 pi over 3 divided by 3. So this here is your answer. So that's the second one. That's how you work it out. Hopefully that makes sense. And yeah, that's how you do it. Thank you.